I'm working on this John Deere 110 garden tractor. This is part 13 of a multi-part series. In the last video, I tested the armature to make sure it's okay. Now I only have a few more things to do before I put the starter generator back together. This is the main housing. First is the visual inspection. Look for loose wires or loose connections. Make sure the coils look normal. Don't want to see any exposed coil windings. These terminals usually need tightened up. The plastic insulator squashed down over time. That's pretty normal. Next, I want to test those windings there. Looking at the picture in the book, both coils are connected to their own terminal on the outside, and the other end of both coils are connected to one of the brushes. As long as the armature's not in there, both coils can be tested without removing them. Here's a wire coming from each coil, and they're connected to this brush, so I can test from this screw terminal. The other brush holder is riveted to the case, so that's the one connected to ground. I'm going to turn off the auto ranging. I want to read ohms directly. I'll hold the leads together and see how low the number goes. That stabilized at 1.4. I'll try it again. Okay, it stabilizes at around 1. If I check this post, it gets to about 1. That would be the starting coil. And this one stabilizes at about 8 ohms. Check them again. I get about the same readings, so that looks good. Now these 3 points should not be connected to ground. And this one over here should be. That all looks good. I have this pile of parts from working on starter generators. I'll pick out the best brushes to use on this project. That's the best pair. I'll use those. Here's some new ones. These used ones are almost as big as the new ones. So maybe I can claim they're almost as good as new. The old one was mounted so the wire came close to that post. I'm going to rotate it towards the outside a bit. Now the wire stands up where it would rub on the back plate. I'll put it like the old one was. Yeah, that works better. That's why it was like that. I need a screwdriver with a smaller tip to fit into the screws. And I have to support the back side of this or it'll bend down. That looks good. You should be able to flex the brushes in and out without any rubbing or binding. One last thing. There was only one lock washer. Here's another one for this post. Okay, done with that part. I'm ready to start putting things back together. There's two spacers here and they're different thicknesses. The wide one goes on this side. The bearing seal rides on the outside of it. The narrow one goes on the outside to make sure whatever pulley is on there doesn't hit the casting. The big spacer goes on first. The bearing plate should slide on there. The small spacer goes on the outside. Now I need the woodruff key. This is the one that was in it. I need to file down the burr that I caused, trying to get it out with the punch. Now I'll try to mash it in place with these big pliers, and the pulley should go right on there. I like to put the pulley on first, because I want to hold the armature to tighten the nut. Grip the armature on the metal laminations, not on the gaps between the laminations. This would have been easier to do before I put on the end plate, but I forgot. I'm going to clean up the commutator surface with some emery cloth. I like to stand this on end in the vise. You need to know where this dowel pin hole is, and you don't want to grip it tight or you'll bend the pulley. Here's the dowel pin that has to go in that hole there. It only goes one way. I'm going to set this down on end with the dowel pin away from me, and I'm going to grip it with two hands here, using my thumbs to push the brushes back into their sockets so I can get the brushes around the commutator. Make sure nothing's touching the armature except the brushes. Now I want to find the dowel pin hole. Here's the other end plate. It's clean but no bearing. And here's the bearing already packed with grease. There's a seal on one side of this bearing. It has to go towards the armature. The open side goes towards this cavity in the end plate. So I'm going to pile some grease in the cavity. You want the cavity full after the bearing's pushed into position, so you only want to fill it halfway. I'm going to start the bearing into the end plate with the light rubber mallet. And I don't want to go very far. There's no stop inside that bearing bore, so the bearing could go too far in. Now hopefully the bearing goes onto the shaft until it seats on that shoulder. There it is. And now the bearing needs to go deeper in the end plate to close up the gap. You have to line up the dowel pin on this end plate before you can close it all the way. I cleaned these bolts while nobody was looking. Make sure there's no gaps around the end plates. Everything looks like it's where it's supposed to be. There's going to be some drag when you spin it because of the grease in the bearings, the seal rubbing, and the brushes riding on the commutator. I replaced those worn out end plates, so there's more metal on the back of this one and on the front of this one. But this part has some wear too, so there's still too much clearance. That means when you tighten the bolt, it puts a lot of bending stress on those cast iron ears. I looked around to see if I had one of these, but all I have is ones like this for a wheel horse. The bolt hole pattern on the block is the same, and the length is the same to fit the same type of starter generator. But it's a totally different height. I want to know how much this is worn, so I'm going to measure it. This wheel horse part is 7 inches and 107 thousandths. The John Deere part is 7 inches and 90 thousandths. So there's 17 thousandths worn off of this John Deere part. That's about 1/64th of an inch. Well, that's as far as I'm going this time, because I don't have a part like this. But I just bought one on eBay. It should be here next week. Alright, that's it.